Okay, well, let's just do the quiz, I guess.
Okay.
How was this lesson for you?
It was kind of confusing at first on what I had to do, so I had to actually watch the tutorials. And then after watching the videos, I'm like, really? It was that easy? Duh.
I did the exact same thing. Because when I was reading it, it just sounded kind of confusing. Then the video, it was like, oh, duh, this is exactly what we've been doing like all semester long.
Yeah. So I was like, oh, okay, this is easy.
Yeah. But I still can't figure out how to get the degrees of freedom.
I don't think I figured that one out either. I mean, the only thing that I can see is that we're supposed to show it under the ANOVA.
Yeah, and so that's what I did. I like pulled up the ANOVA one, and I still was getting something completely different than what they would show. So I'm gonna I don't know if I should email her about it or what, but that was confusing to me. But that was really the only thing but they didn't ask that on the homework or anything, so I'll let it go. But
Yeah,
it was kind of confusing.
I agree.
So I guess we'll see if they ask us on this quiz. Okay, you ready?
I'm ready.
Okay. I'm just going to pull up the Excel things here. Okay. The true linear regression equation is y equals b0 plus b1 x, where b0 or b naught and beta naught and beta 1 are unknown. What are the null and alternative hypotheses for beta 1? So beta, it should be beta equals 0, and that alternative does not equal 0, right?
Yeah.
Okay, so the third one. The residual, okay, is the difference between the observed value y. I think it's the third one. So let me double check. The difference between the observed value of y and the value that would have been predicted by the regression line.
Yep, you're right.
Okay. Question 5. A plot of residuals supports using linear regression when the residuals look... Oh. I think it's when you don't see a pattern, I thought.
I thought it was when you see a pattern. So that last one.
A lot of residuals supports using linear equation when... Oh, I actually think it's when no megaphone shape is in the residual.
Okay,
oh, wait, that's not an option. Okay, so you see a pattern in the residuals.
Mm-hmm.
Okay. Okay. So the last one. For the next 8 problems, use the data found in the math self-efficacy. Use the confidence variable. Use the confidence variable as the explanatory variable and the score variable as the response variable. Okay. Compute the residuals for the data using software. What statement best describes the residuals? Okay, so the confidence is the explanatory. Okay. So what statement best describes the residuals? So I don't see a linear pattern, and they aren't all negative. So I would say the first one.
I would agree.
Okay. Based on the QQ plot for these residuals, what can you say about the residuals? So go back over. I wish they had a QQ plot on this Excel spreadsheet.
Right, that would be nice.
Yeah, it's just a lot of moving around. Well, it looks like a straight line to me. So that means that they are normal. Oh wait, that's not an option. Residuals are clearly not normal. Residuals are fairly normal, I guess. That's what I would say.
Okay, yeah, I would agree.
Okay. Use software to create a scatter plot of the data. Given the scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. Okay. I'm just going to double check this again. Okay. So there is a linear relationship between X and Y. I would say that's true, would you?
Yes.
Okay. The variance of the error term is constant for all values of X. Is that the one that we just assume is always true?
The error term is the QQ plots are close to the line, which they're close to the line.
Okay, so that one too then. And then the residuals are normally distributed. Which, yeah.
Right, because you wouldn't see any type of a megaphone shape.
Yeah.
Now, the X values are measured without error. That one says that you can't check that one directly.
Right. Same with the last one too. The observations are independent.
Uh-huh.
Okay. So all of them?
I would say yes.
Okay, need to. Okay, that makes it easy. Okay, what is B1, the estimate for the slope? 12.695.
Yeah.
Now construct a 95% confidence interval for beta 1. Input your answers for the lower bound and the upper bound. So the lower bound, 10.674.
Uh-huh. And then the upper would be 14.715.
Yep. Okay. Question 12. Based on the evidence and using the levels of significance, alpha equals 0.05, what decision would you make regarding the hypothesis test? So the p-value is basically 0. So I would say we reject the null. So we reject the null test because the p-value is less than alpha.
Yes.
Okay. You know, how many times we've had to figure that out, I still have to look at my little card to figure out if I reject it or don't.
I'm the same way, and then I use it to figure out if it's sufficient or insufficient.
Yeah, okay, I'm glad I'm not the only one. I think I would know this by now.
Yeah, no.
So for hypothesis test, for beta 1 or the slope, if you reject the null hypothesis, what does it mean? So when we reject the null,
You have sufficient evidence.
yeah, we should have sufficient evidence that the slope, where did I write this down? Sufficient evidence that there is a linear relationship between the two. Sufficient evidence to conclude that the slope of the regression line is not 0, I guess. So the last one?
Yeah.
Okay, then use the data found in the crocodile one for the next 5 problems. Head length was used to predict body length. Okay, so head length is the X. For this data, which variable is the dependent variable? Is it the head length? Wait, I wrote this one. No, sorry, the dependent variable is the response variable. So it's the body length.
Yep.
Okay, thank you. Now construct a 95% confidence interval for beta 1. Input your answers for the margin of error, lower bound, and upper bound. Okay. So 0.443 for the margin of error.
Yeah.
Okay. So then the lower bound 7.128, upper bound 8.103.
Yes.
Cool. So based on your lower bound and upper bound from the last 2 problems, what can you say about beta 1? I'd say the first one.
Yes.
95% confident. I'll continue to value. Okay. Awesome. Looks like we missed a couple. Let's see. So I think for question 5, I think the answer is the residuals look normally distributed.
Okay.
I don't know for sure though. What do you think?
Let's see, because I was just reading through it. Megaphone shape occurs. Suggests that they're not constant. Not normally distributed. Which are not related. I would agree.
Okay. So the residuals look normally distributed. I mean, that makes the most sense, I think, because megaphone is bad.
Right.
And then there shouldn't be a pattern, I think. So, and positive and negative don't have anything to do with it.
Mm-hmm.
Okay. 6. So then question 8. What did we do wrong there? Use software to create a scatter plot of the data given the scatter plot, residuals plot, and the QQ plot. Which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply. Oh, okay. Well, I'm going to try to enter in all that information again. I mean, I guess the residual one kind of looks more like a pattern.
Did you get that one wrong again?
Yeah, we got question 8 wrong. So maybe, since questions 1 and 3 have to do with residual, maybe we can uncheck those ones, but then mark 2, 4, and 5.
Because I went back through and I looked, and it is a linear relationship between x and y. The variance term is constant for x values, I thought I saw.
Well, because on like this,
Yeah.
on this, like that chart thing that they gave us, for a linear relationship, the scatter plot has to have a hot dog shape, and the residual plot, there can't be any patterns.
Right.
So both of those have to be true, right?
Mm-hmm.
And like, I didn't think there was that big of a pattern, but I mean, I don't know. Now I don't know, because it almost looks like now you can kind of, like, is this what yours looks like?
Yeah.
Because you can kind of say that fans out a little bit because it starts smaller and then gets really big.
Uh-huh.
So I would,
Liar too.
yeah, and there's that outlier. So I would say that this one isn't what it should be, because there shouldn't be any pattern at all.
Right.
So since there is a pattern, that would make the residual plot inaccurate, I guess. So that means, I think that means that there is not a linear relationship.
No.
I don't know.
I don't know either, because I know on that one, the only thing that they described is that you don't want to see a megaphone shape, and it's like, okay.
Yeah, and I don't feel like the megaphone thing is very, I don't know, descriptive. Like, I guess I just wish it was more like black and white, like, oh, that's obviously a megaphone, or oh, that's obviously not.
Yeah.
They didn't really give us much on what is and what isn't.
I agree.
So what do you want to put for that one then?
For that one, I'm kind of leaning towards looks normally distributed or even all positive, but that's not the case. The residuals aren't going to always be all positive.
Oh, are you talking, is that the other question?
5.
Yeah, so question 5, I think we still, yeah, that one I think the residuals look normally distributed.
Yeah, I would agree there.
Sorry, it's more question 8 that I'm not sure. Did you get question 8 right?
I haven't resubmitted mine again. I almost done.
Okay.
But I looked at the under section 3, under checking the requirements of a simple linear regression. It gives you like a list of 5 different things. There is a linear relationship between x and y. The error term E is normally distributed. And then there's the variance of the error terms is constant for the values of x. X's are fixed and measured without error, so that one's considered known constant, and the observations are independent. The only one I did not see on there really was the residuals are normally distributed. So I'm going to pick the first 2, not use the middle one, and the last 2 is what I'm going to put for my answer.
Okay.
Let's see if I get that right.
So sorry, tell me again what you did. You chose the first 2? Okay, and not the last 2?
Yeah.
Okay,
and
so
I still got wrong.
Okay, well, I'm going to put the 2nd and 4th and 5th. I'm going to see what that does.
Okay.
We got question 5 right?
Yeah, I know.
I still got it wrong too, so.
Okay. Huh, I don't know what they're looking for then.
I don't either. That's weird. Well, at least they didn't ask us about the degrees of freedom, because I still don't know how to do that.
Yeah, no, me neither.
Okay. Well, I'm going to work on the next part of our final project. I noticed it isn't due till Saturday, so I might not have it done for a couple of days, but when I do type it up, I will email it to you so you can see it.
Okay, awesome. And I took a look at the PowerPoint that we need to do, and that just before we called. And I kind of have started a little bit. I have an idea of what I want to do, so I'll have that probably done maybe within the next few days as well.
Awesome. Sounds good.
All right, well, I will see you on Thursday then.
Hey, sounds good. Thanks.
All right, yep, see you.
See ya.
Bye.